This is the lecture number 4 for the chapter application of derivative for the class 12th, and we are discussing the exercise second, that is 6.2. We are starting with question number 5. Now in these types of question, you have to find in each interval the function is strictly increasing and strictly decreasing. There's a fixed method to do these types of question. Now because it is a polynomial function, therefore it is always continuous and differentiable on R. So we will find the interval it is increasing or decreasing. So what you have to do in these types of questions, simply you find its derivative, and first derivative put equal to 0, find the value of x, that is the turning points of the graph. So now break this, you have to find in which interval it is increasing, decreasing. So you have to take all real numbers from minus infinity to plus infinity, and these value of 3 and minus 2 will be between these. To put in the increasing order, to minus infinity, minus 2, 3, minus infinity, minus 2, 3, and up to infinity. That is there will be 3 interval from minus infinity to minus 2, from minus 2 to 3, from 3 to infinity. There are 3 interval, means this graph is like this. Between the 2 points, the graph is turning at 2 points, that is like this, like this. It is turning at this point, that it is turning from infinity to this, from this to this, and from this to this. There are 3 intervals will be there in this graph. First is turning point is here, then it is turning here like this. From minus infinity to this it is increasing in my example. From this to this interval it is decreasing. From this to plus infinity is increasing. So like this you have to tell in which interval it is increasing and which interval it is decreasing. So first of all, we check the increasing and decreasing, whether it is increasing or decreasing in their particular interval. So first derivative is 6x minus 3 x plus 2. This is the first derivative. Now let us take the first interval from minus infinity to minus 2. Now in this interval, this bracket will be negative. You think any value in this interval, this bracket always be negative. Now this value will also negative. Think any value in this interval, this bracket will be negative. Let us take, if I take minus 3 in this, between this will be negative and this will be negative, and total will be positive. So it means first derivative is positive in this interval. So it means this function fx will be increasing, strictly increasing, because it is a polynomial function in the interval from minus infinity to minus 2. Minus infinity to minus 2. Now let us take the first derivative in the second interval, that is from minus 3 to minus 2 to 3. Now again this is the first derivative. You think any value between it, in between it. Let us take, I am taking 0. So it will be negative, it will be positive. So negative, positive, negative. So it will be a strictly decreasing in the interval minus 2 to 3. So like this you can easily tell whether it is increasing or decreasing. Simply you have to find that first derivative is negative or positive in the particular interval. Now in the third interval, 3 to infinity, this is the first derivative. Think any value from 0 to infinity. Let us take it as 5. It will be positive, it will be positive, it will be positive. So first derivative is positive. The function is strictly increasing in the interval from 0 to infinity. So the function is increasing in 2 interval from this to this, and is strictly decreasing in this interval. So it is increasing from minus infinity to minus 2 in the second part, and 3 to infinity is increasing, and it is decreasing only in the one interval, that is minus 2 to 3. Similarly in the question number 6, first part, this polynomial x square plus 2x minus 5 is given, and to find in which interval it is strictly increasing or decreasing. So because it is a polynomial, therefore it will be continuous, as well as it will be differentiable. So find its first derivative, 2x plus 2, put it equal to 0, so x will be equal to minus 1. So there is only one turning point of this graph, because 1 degree 2 is there, so it will be a parabolic function, and therefore it will have only one turning point like this. In parabolic function we have only one turning point, either increasing then decreasing then increasing, or like this, turning point increasing and decreasing like this. So first interval is from minus infinity to minus 1, and the second interval from minus 1 to infinity. So its first derivative is 2 x plus 1 in the interval minus 1 infinity to minus 1 I am checking. You think any value between it, put in this bracket, it will be negative. Let us consider the value of x as minus 3. In this bracket will be negative. So plus into minus will be minus. So the function first derivative is negative. First derivative is negative. So it means fx is decreasing, strictly decreasing in this interval. Now let us take the second interval, fx dash x is equal to 2x plus 2 in the interval from minus 1 to infinity. Consider any value of x in this interval. Let us take 0. This bracket will be positive, 2 is positive, and both will be positive. So fx is strictly increasing in the interval minus infinity to minus 1 to infinity. So like this, you have to do these types of questions for increasing and decreasing functions. Let us take another part of this question number 6. Let us take the third part. We have fx is equal to minus 2x cube minus 9x square minus 12x plus 1. Again, because it is a polynomial function, therefore it will be continuous on R. Now its first derivative will be minus 6x square minus 18x minus 12. Find the derivative of this. Put it equal to 0. Find the value of x. The value of x we are getting as minus 1 to minus 1 and minus 2. So the interval will be minus infinity to minus 2, minus 2 to minus 1, and minus 1 to infinity. There will be 3 intervals in the graph of this function. Now first derivative is minus 6x plus 2x plus 1, and we are finding in the interval minus infinity to minus 2 in the first interval. We are finding whether it is positive or negative. Consider any value in this interval. I am taking as minus 3 in mind. So if we take x minus 3, it will be negative. It also negative. This bracket negative, this bracket negative, and this is negative. Minus sign is also there. So total will be negative. So fx is strictly decreasing in the interval minus infinity to minus 2. Now consider the second interval, that is minus 2 to minus 1. So f dash x is equal to minus 6x plus 2x plus 1 in the interval minus 2 to minus 1. Let us consider any value between this. I am taking as minus 1.5. So it will be positive, it will be negative. The total will be, first derivative will be positive. It means fx is strictly increasing in the interval minus 2 to minus 1. Now let us take the third interval, which is minus 1 to infinity. First derivative is minus 6x plus 2x plus 1 in this interval minus 1 to infinity. Let us consider any value in this interval. I am taking that 0. So this will be positive, this will be positive, and minus 6 is there. The total value is negative. So the fx is strictly decreasing in the interval minus 1 to infinity. So in two interval it is decreasing, and in one interval in it is increasing. So put the union sign between these two intervals and single this. Like this you have to write in the end. Now in the E part, x plus 1 ka whole cube, x minus 3 ka whole cube, do the derivative smartly using the product rule. See what you are getting common in this. We are getting common as x plus 1 whole square, x minus 1 whole square in the bracket. It will become x minus 1, x minus 3. So it will be x 2x minus 4. So take 2 common, it becomes 6. So x minus 2 is the derivative. Now if it put it equal to 0 like these types of questions, this question become very lengthy, but it can be done. But from the derivative of this function, it is we can see it directly that these are 2 whole square, which will always be positive. These two bracket will always be positive. So f dash x will be negative or positive depending upon x minus 2. That is, if f dash x is greater than 0, then x minus 2 must be greater than 0, because these two always be positive. So if f dash x is positive, then x minus 2 should be positive, means greater than 0, so x greater than 2. Now if f dash x less than 0 means negative, then x minus 2 should be less than 2. So for the increasing function, x should be greater than 2, and for decreasing function, x should be less than 2. And because it is a polynomial function, though it will be continuous, so therefore it is strictly increasing from the interval 2 to infinity. 2 say greater. So 2 to infinity it will be increasing, and 2 to negative side means from minus infinity to 2 it will be decreasing. So by do it smartly, we have done this question in less steps. Now if you do like this, putting it equal to 0, find the value of x, it become lengthy, but it can be done because these whole square will be positive, and this f dash x will be positive only when x minus 2 is positive, matlab greater than 0, and f dash x is negative, that is less than 0 if x minus 2 is less than 0. So like this, we have obtained this question very easily. Now in question number 7, there is a function. Again, you can do it smartly. This question, it is given that y is equal to log 1 plus x minus 2x upon 2 plus x. Now find its derivative. You have to find that it is increasing for x greater than minus 1. You have to show that this function is increasing for x greater than minus 1. So see it very carefully. To find the derivative of this, dy dx will be equal to 1 upon 1 plus x. Find the derivative of this by the quotient rule. Simplify this expression. I am getting this x square upon 1 plus x, 2 plus x whole square. By simplifying this expression, I am getting this x square 1 plus x and 2 plus x whole square. Now you have to prove that this function is increasing. So when this will be increasing? When this fraction should be greater than 0. Now this fraction will be greater than 0 when 1 plus x is greater than equal to 0, because x square is always positive, greater than equal to 0, and 2 plus x whole square always greater than equal to 0. So dy dx only depends on 1 plus x. For decreasing or increasing means for negative or positive value depend on only 1 plus x, because x whole square will always be positive, 2 plus x whole square is always be positive. So dy dx depends whether it is negative if 1 minus x is negative, that is less than 0, and dy dx will be positive if 1 minus x is greater than 1 plus x is greater than 0. So you have to find y is increasing. So means you have to prove that d by dx is greater than 0. So when the function d by dx is greater than 0, 1 plus x should be greater than equal to 0 or greater than 0. So 1 plus x greater than 0 means x greater than minus 1 for the increasing function. For d by dx should be greater than 0, 1 plus x should be greater than 0, because x square and 2 plus x square is always greater than 0. So this is the question number 7, and we have done it directly without putting it equal to 0. From the d by dx fraction, we have easily find when it will be greater than 0. It will be greater than 0 when 1 plus x is greater than 0, because x square and 2 plus x whole square is always greater than 0. So it depends on only 1 plus x. Okay, we'll discuss the remaining question of this exercise in the next lecture. Thank you.